welcome to virtual students. Turn to page 805. We're talking section 15.3. Tangents, new concepts. 15.3 tangents. 805, at the top of the page, there's a definition of tangent and point of tangency. Write those in your notes. A tangent is a line which is in the same plane as a circle and intersects the circle at exactly one point. That's a tangent. It's a line which is in the same plane as a circle and intersects the circle at exactly one point. Those are the key terms of the definition. That exactly one point is called the point of tangency. That's called the point of tangency. All right, let's take a look at 3 different scenarios for this topic. Number 1, scenario number 1, we have a circle and we have a line that actually intersects the circle in 2 points, like that. When that happens, it is called a secant. So there's scenario 1. Okay, here's scenario 2. I have a circle, and it intersects the line, or the line intersects the circle at exactly 1 point. That is a definition of a tangent. And scenario 3, make sure it's on the screen here. We have a circle and the line does not intersect at all. There's nothing to do there. So we're going to focus in on that scenario. Okay, so we have a circle with a tangent. Now let's make a bigger picture with that. All right, so I have a circle and I have a tangent. It does not matter where you make the line, doesn't matter which side of the circle. Okay, so you can't see it, but it just touches right there, right? Barely touches. Okay? And as we commented before, that is the point of tangency. Okay? The point of tangency. At the top of page 806, there is the tangent radius theorem. Please write that in your notes. The tangent radius theorem. Basically, it says that it is perpendicular at the point of tangency. Perpendicular, 90 degrees. Okay, so looking carefully at this. Now, it's got to be a radius. It's got to go through the center of the circle. That's the center. This is a radius. And then it makes a 90-degree angle. That's the tangent radius theorem. I'll let you write it down. Okay, so what does that mean? All right, well, what you're going to see then in some problems is if I draw in another line or segment, lo and behold, what do I have? A right triangle. And anytime that we have a right triangle, we then can use the Pythagorean theorem. So be ready to use that when it comes time for your homework. Okay, questions on that? All right, good. Okay, so let's go to our final illustration before we do some examples. All right, so let's say that I have a circle and I have a point out here beyond the circle, and there are two tangents that are drawn. So there's my picture. So I have a circle. There's my center. Okay. Drawing the radius here, 90 degrees. Drawing the radius here, 90 degrees. Everyone see the picture? Okay, now I'm going to outline. I have a quadrilateral. Four-sided figure. Everyone see that? Anytime that I have a quadrilateral, the interior sum theorem, the angles all equal 360 degrees. Okay, and so if this is 90 and that's 90, well, let's call the central angle here. This is the central angle right there, central angle. And then this is just that angle outside. Well, then these angles have to be supplementary. Because they all have to be 360. It's a quadrilateral. And so the angles outside have to be the outside angle and the center angle have to be supplementary. So angle 1 plus angle 2 is equal to 180 degrees. Oops, 180 degrees. They are supplementary. All right, we good there. One last piece of info that you're going to see is when I draw a tangent in, okay? So here's a tangent, and I draw another tangent from that line. I can only draw two, by the way. Think about it. I can't draw a third from this point. I can only draw two, right? Okay, but as I draw them in, one thing that is true is the length from here to here is the same as the length from here to here. It has to be. It doesn't twist. Right? There's no way to do it. If it's a true tangent, they have to be congruent. Okay? We good? All right, we're going to come back to this sheet and review it in just a little bit. For now, turn to page 8. Nope. Page 810. Page 810. We're going to do a few problems from the homework. Okay, so first one we're going to look at is number 7. So look at number 7 on page 810. And they give us a circle in the chart. I'm not going to recreate it, but they want us to find the radius. All I have to do is count from the center out to the edge. From the center out to edge of circle. What's the length there? 3? Okay. So there's one solution, one part of the solution. Radius is 3. Look carefully. Find the point of tangency. Looks to me that it's at what, -3? Is that positive 1? The coordinate? Yeah. -3, positive 1. That is the point of tangency. That's the second thing they wanted us to find. Okay. And then the last thing I want to find is the equation of the line. Well, we have a vertical line. Back from algebra, whenever you have a vertical line, it's just y equals wherever it crosses the coordinate. So look at it carefully. Is that -3? -4? Where is that? -3. And so the equation of the line is y equals -3. It would be the other way. If it were a horizontal line, it would just be x equals. Okay. And the equation of the line. All right, questions on number 7. That's it. We had to find those 3 things. Good? Okay. Let's go down to number 10. Let's do number 10. Okay, so here we have a circle. I'm not going to get it exactly as they have it, but I'm going to get it close. And they intersect. This is y, and this is y squared over 7, I believe. Right? Okay. Now, they want us to solve for y. Well, as I just said, these segments have to be the same. Those are congruent. So then I can create an equation where y equals y squared over 7. Now it becomes an algebra challenge. How do we solve y equals y squared over 7? The first thing we're going to do, let's get rid of that fraction. So we're going to multiply by 7. Whatever I do to one side, I have to do the other. Okay, so now I'm going to have 7y is equal to y squared. Now you would think maybe, did I take the square root of both sides? No, because I don't have my y's on the same side of the equation. Okay, in fact, that's a y squared and that's a y. Those can't even combine. They're not even like terms. Let's just get them on the same side of the equation, then we'll figure out what to do. So let's subtract 7y. So now I have 0 is equal to y squared minus 7y. Does that look a little bit better? You remember what to do at that point. Okay, so there is maybe you didn't learn this in Algebra 1. You are going to learn it in Algebra 2, but there's a method to solve this called completing the square. This is a perfect square trinomial. Okay. Do you remember if I had this? Let me show you this. If I had that and I told you to solve, would you remember how to do that? Does that look familiar? Does that look familiar? Oh, we need to make our signs different, sorry. I was doing that in my head. That should be minus 6 and that would be plus 9. You remember factoring? And then once we got here, what would we do? Set them both equal to 0. Okay, it's been a long time, right? That's Algebra 1. It's been a long time. That's how you factor and solve. Okay. That's exactly what we have to do right here. Now, it's not the exact same, but it's the same approach. To factor this, we don't have that third term over there where we can do a trinomial factor. Okay? So it's actually a little easier. We just factor what are the things that are in common between these two terms. The only thing that's in common is a y. Once I factor out a y, what am I left with? A y minus 7 and a y. I have a y and then it times the product of y minus 7. Then I take each term and I set them equal to 0. So I go y equals 0, y minus 7 equals 0, y equals 7. So as you can see, I have 2 solutions. Just like I had 2 solutions over here. Okay? Now, well, let's evaluate. What about y equals 0? Does that, could a length from here to here have a length of 0? No. That doesn't even make sense. So for geometry, kind of it is an answer, but it's not a solution. You know what I mean? Algebraically, it's correct, but it's not a solution of the problem. Because you can't have a length that's equal to 0. So we can't eliminate it. Does that make sense? So what about 7? Could that work? Yeah, y equals 7. 49 over 7. Yeah, that works. Okay? So that is our solution, y equals 7. Good? On number 10. You're going to have to do another one like that where you're factoring on number 9. But I'm going to let you do that. All right, let's go to number 14 on the next page. I'll try and quickly recreate the picture. I believe this angle is 56. All right. And they want us to find, I know there's more stuff in there, but for this problem, they just want us to find AOB. Isn't that right? Center, AOB? Okay. Well, we just learned that this angle and this angle are supplementary. So the central angle where the question mark is, and this angle out here, they're supplementary. That means their sum is equal to 180. So all I have to really do is take 180 minus 56 and 124 degrees. Questions? Okay. Before I give you the assignment, let's review. Back to our tangent definition. It's a line which is in the same plane as a circle and intersects the circle at exactly 1 point. So I've highlighted the key parts of a line, intersection, exactly 1 point. There are 3 scenarios that this occurs where you have a circle and a line. The one that we're talking about is this one, or it's a tangent. It's at the point that they intersect, it has a special name. It's called the point of tangency. And it is 90 degrees. 90 degrees at the point of tangency. Perpendicular at the point of tangency.
What's the one with no connection fault?
What's the one with what?
With no, like the line does not.
Nothing. It's just a circle and a line. Yeah. And remember that whenever you have 90 degrees, that creates a right triangle, and you may have to use the Pythagorean theorem. Okay. All right. Let's go to the last 2 pieces of info. The central angle here, which is angle 1, and angle 2, have to be supplementary. So they add up to 80. And then the angles that are created, of course, are 90. And with this point out here, that makes these sides congruent. Questions? Here's your assignment. I've already posted on Canvas if you've seen it today. So here's your assignment. Page 809. Page 809. Starts on page 809. And then 4 through 15. Except number 11. You don't have to do that one. And then number 18 and 19. Looks like you have about 10 problems. You got the rest of the time to work. It's already open, so if you get it done, you want to submit it, you're welcome to do that. Page 809, 4 through 15, 18, 19. You do not have to do number 11. Okay. Let me load this for the virtual students.